Because I saw Yahi 10 minutes ago. I was talking to him in the office. I'll see you in a few minutes. He's like, yeah. Well, I can see which students care the most about physics.
Yeah, of course. I suppose that does something.
Yeah, that's true too.
Even Siobhan was not here. But
She
she wasn't with them, so we don't know anything about her.
She's in the library.
She was, supposed to be in the library. But I don't think the library
Is there something
that one that she skips physics for.
Yeah, no, that's believable. But is there something due tomorrow?
No.
So there's no special reason to skip this class other than the sunshine?
Yeah.
Tut. Right, we're going to have a look at interference. This is a pretty big topic. Don't know if we'll get it covered all today. We'll see. Wow, come in. Wow. About time you showed up. Oh my goodness. Is that Turbo's house?
Yeah.
Come here, let's see it.
Do you want to throw it?
No, I don't really. I want to see. Does it have any water?
No.
It needs some water.
No, it won't, because the lid also have water.
But a little water on the leaf, no? Interference. Did you write that down?
I only have 3.
Because we are both good.
Yeah. Come on. Sit down.
Just sit down.
Sit down.
See?
Oh, come on, guys. Not cool. Come on.
Is that Turbo?
No, you weren't here.
Yeah.
It is, yeah.
But then no one was here, so then I looked it up on the phone. This creature sit here?
Sit down, Omar, before I do something you regret.
What?
Oh,
Guys, you're all late. Come on.
I told you to hurry up.
Right, so your choices are sit down and don't get a slap, or stand up and do get a slap. Can we please start? I'm waiting here for people. Interference. Okay, so what exactly do we mean when we say interference? Wong, please. Interference is when 2 or more waves combine to form a new wave. Pen and paper, come on. Interference is when 2 or more waves combine to form a new wave, and the principle of superposition states the net amplitude of the new wave at each point is the sum of the amplitudes of the individual waves. Basically, heights of waves add or subtract as shown below. So if we have one wave like this and one wave like this and we add them together, we'd have this height plus this height. So it'll be this wave going up, down, add, subtract. So that's why we get this kind of result. To put it maybe more mathematically, if we have one wave, and we'll call it ft, and we have another wave, and we'll call it, I don't know, like this, gt, then adding the waves together makes this. And it's mathematically just ft plus gt. So if this height is x units, x1 units, no, h1, and the height here is h2, then the height here is h1 plus h2. That's what I mean when I say principle of superposition, that the total amplitude is the sum of the amplitudes of each. In other words, waves add algebraically, add in a normal manner. They like to ask these definitions in the exam because waves isn't a big chapter, so they usually make the question longer in the exam by asking definitions. Write them down, FF. One of the F stands for Faisal.
Second.
Yes.
Physics.
Yes, and the other F stands for physics. Yes. Fuang, is Turbo in that cup?
Yeah.
He will get too hot beside the projector. You'll have to put him somewhere else. No, that projector will get very hot soon. Unless you want to cook him and have him for dinner, you should remove him, please. Okay.
Keep him tomorrow, huh?
Yes.
If he survives.
Yes.
Just one die.
We will see. Did you write this down, Lee?
Yes.
Good. Andrew? You got it? Okay.
Now I know we can bring pets to school.
Pets like this are okay.
You're going with a pit bull tomorrow.
Yeah, but see, I can't squish a pit bull, so it's not okay then. Alright, do you have this? Continue. Come on, Fuan. Turbo could write this quicker. Come on. Faster. Frappuccino? Continue. Continue? Oh my goodness, I'll give you 5 more seconds. 1, 2, 3, 4,
They also right.
5. He's done.
Oh.
Continuing.
Like it.
Stuck. I did click it, it's stuck. I must have a big
Try.
picture. There we go. Right. 2 waves are coherent if they have a constant phase difference. Now, I'll remind you of what phase difference is. Phase difference, when you have 2 waves, I'll draw them here, this wave, and we'll put one underneath here. That's not great. Close enough. So the phase difference is the distance between the 2 peaks. Or likewise the 2 troughs. That's totally off, sorry. But it's the distance between the peaks. That's the phase difference. They're coherent if the phase difference is constant and they both have the same wavelength. So constant phase difference and identical wavelength. As a graph, this is what it looks like. So do you notice how here's the peak here and here's the peak here, and the difference between them is this much? Here's the peak here, here's the peak here, and the distance between them is this much. Likewise here.
So they are basically identical, but they just...
There's some kind of shift between them, yeah.
They started off different times.
Yeah, one is delayed. So they have the same wavelength and a constant phase difference. We say these waves are coherent. These are coherent waves. An important word for the exam, and again, a frequently asked question on the exam. What are coherent waves? So please write down this definition carefully.
So this is the definition for coherent wave.
A kind of specific phase difference.
Constant phase difference, yeah. Yeah. Did you say specific? Yeah, yeah. Did you write this down? Okay. Who am I waiting for? Oh. Continue. You wrote this down? Wong, you wrote this down? Omar? Okay, continue.
No.
Are we just waiting for Wong?
Again.
She's not a man, so can you leave her behind?
Yeah, we can. So long, go on. Continuing. Yes. Does anyone remember the verb propagate?
No.
Well demonstrated, but maybe using other words. Yes, using.
Vibrate.
Yeah.
Pro-
Yeah, propagate is just a fancy verb that means moving waves. You know. Thank you for the visual demonstration. When two coherent waves propagate together, move together from two different sources, eventually their peaks will meet. And we say the path difference is the difference in the distance each wave has travelled. So, in other words, if I was to draw this, imagine we have one source here, source 1, and one here, source 2. And let's say the wave is coming out this way. Hang on, let me try that again. One wavelength, two wavelengths, three wavelengths.
Where's it going?
That's just the way I drew it moving. It's moving this way. Yeah, and then here, let's say it's here. One wavelength, two wavelengths, and maybe this is some kind of wall, and then half a wavelength. So how far has this wave travelled? It's travelled 3 wavelengths. Now if these are coherent, the wavelength here should be the same. So this one has travelled 2.5 wavelengths when they meet here. So we say the path difference is half a wavelength. In other words, one wave travelled half a wavelength more than the other wave. What about if they met right in the middle? Then the path difference here is 0. They've each travelled the same amount. So for there to be a path difference, they must be at different angles when they meet. Yeah?
So don't they meet twice?
By meet, I mean meet at a wall or something at the end. Yeah. This picture's not great. Maybe I have a better picture. Oh, I do. So here the path difference is 0. And here the path difference in this example is half a wavelength. You could try to draw this, but you need the definition. Now, I know it sounds like in the question, I think I need to rephrase this because it sounds like what I'm saying is,
They start at the same point.
and they, well,
Like they are coming from the same source.
Yeah.
At the same time.
that definition could be greatly improved.
And the diagram.
The diagram's okay, leave the diagram alone. It's whoever wrote that definition. He really needs talking to. Anyways, for exam purposes, all you need to know is what path difference means when they ask for it. And what they want to know is literally the difference in the length of the two paths. But you might have guessed that from the name. Uh-huh. Oh, Okay. Good idea. Continue. Snails actually, what's the word? Androgynous, isn't it? They have no set gender, I think.
Yes.
Yeah, isn't it? Is it that they're neither male or female, or that they're both male and female? Can't remember which way it is. What? What's
So,
different? Wait, what are you saying?
so it could be a male or a female.
No.
I mean male different and female different.
So
there are both male and female? I don't think so.
No. No.
Only the, what's that called,
Antenna?
No, centipede.
No.
One.
yeah.
The one.
Yeah.
That is both. I mean that is, can be male and female.
Oh, it can be both at the same time?
Yeah.
Ah.
Only that.
That's a different word. Yes.
So we refer to them as they?
It. Yeah.
The answer is yes.
No, I don't think Turbo will mind. It doesn't mind. Yeah, that's both at the same time, isn't it?
Yeah.
Whereas androgynous is neither at the same time?
Yes.
Yeah, okay. I think that's what it is. Alright. We have two different types of interference. We have constructive interference, which means the waves combine to form a bigger wave. So, waves combine to form a bigger wave. And you can guess what destructive interference is. They combine to form a smaller wave. Interesting one is completely destructive interference, is when the waves cancel each other out. So here's an example of completely destructive. These two waves combine to form no wave. And here's an example of completely constructive. The wave is added to an identical wave, and we have a wave now twice as high in amplitude. Okay, write these down, and the diagrams will be useful too. Turn that fan on, Faisal, please. I think we would benefit from it. Maximum power.
What?
What do you mean, what?
No, it's cold.
Can't hold anything other than
If we're saying it's hot,
Yeah, now we're talking. Ah, yeah.
what's an engineering class?
Yeah. Now you can just leave it pointing this way, that's fine. Alright, now we're talking.
No.
What? What?
I
If you write faster, maybe we'll turn it down.
Whoa.
What?
If I look through the
Yes?
plates,
Yes?
I can see different colors.
Yes.
Because this is behind me.
yeah, we go and weekend.
Yeah, you can too?
Yeah, it's like a rainbow.
Yeah.
Fascinating.
And opening the rain.
Yeah, maximum air conditioning.
No.
Yeah. Interesting.
But
Okay.
I'm cold.
Sorry, does anybody care? Anybody? Anybody care? That's what I thought.
Also, it should help you to take care of
It would, but that involves more movement.
But I'm cold.
Put your hood on.
I
Hold
will
double.
very trouble.
Oh!
Put your hand on the projector. Yes, yes.
The best I'll do is just keep this towards me. Better?
I think you change the slide to the...
Yeah. Now I have to take my sweater off. Oh, the move. You know how much I hate moving. Alright. Are we just waiting for Fulan? Because I'm going to continue now.
Yes.
Alright, continuing. So, there's a very, very important experiment in physics, and it's a way to tell if something is a wave or a particle, and this is called Young's double slit experiment. You know this one. And what happens here, you've seen it, you have light, and you separate the light into two sources, and you look at what pattern you get on the wall here. So let's see what is happening exactly here. So we have two sources. Here's source 1, and then here's source 2. And we imagine lights coming through. So I'll draw in red the peaks. No, I imagined I've already separated it. Yeah. So here are the peaks. I'll make that a bit bigger, otherwise it'll take all day. And here are the troughs, which are the dips in the wave, and they are, of course, in between. And then let's draw for this one. And the troughs. So, if you look at some place here, when two peaks meet, what will happen to the wave? Will we get something bigger or smaller?
Bigger, constructive.
Yeah. If you have a wave that's high and another wave that's high and they meet, that makes a bigger wave. So, this one here would be quite strong, or, in other words, bright. But what happens if a trough, like here, meets a peak? Destructive. Yeah, if you have a trough and it meets, a peak and it meets a trough, they'll cancel. So this part here, when it hits the wall, will be dark. There's no light wave. So the end result is the two waves combine. The peaks will meet peaks and form bright image on the screen, and the trough will meet a peak and form a dark image on the screen. And this is called a light and dark fringe pattern. Yeah?
What about completely destructive?
It's completely destructive when the peak meets the trough, and in these black regions it's completely destructive. In the white regions, the bright regions, it is constructive.
And what happens when a trough meets a trough?
It's still bright then. The wave still has an amplitude.
Why is it this is a destructive interference?
When what? What's your question?
When the
Trough meets the peak? Yeah, so what's happening? Imagine this wave here. This is the peak, yes? And its height is, we'll just say, 1 micrometer, for example. And it's added to this wave, it meets this wave, and its height here is -1 micrometer. So when these two waves combine, this will cancel this, and you're just left with a flat line here, meaning no wave. This is destructive then. So that's what's happening in these dark regions here. Yeah? important vocabulary in this diagram. Slits, these are slits. Fringe pattern, light fringes, dark fringes, light source, and this is called Young's double slit. A very common question in the exam. Seen it so many times in the exam. 40% of exams have this in it. Very common. So I would like you to draw this as best you can with the names. Please.
I can't understand why you feel it's true and then have a lot.
Yeah, because what's happening is the wave, the wave is spreading out.
Can you make the
What?
real thing?
Huh?
Can you make it the real thing?
Yes, of course you can. You need a light source like the window, a piece of card with 2 holes in it. That's all. Now,
But like the answer only can be 2.
only 2?
No, you can do it with 3 and 4.
Yeah.
No, I mean the asterisk only has
No,
Many. Because the wave spreads out, making many. You know this? Spreads out? You know this word? So, at the beginning it's only 2, but it spreads out to make more.
when you have a light bulb, does it
Huh?
make light in a straight line or does it make light like
But
this?
it's
Oh, we
only
haven't done
bigger,
this
it's
word
not
yet,
without
actually,
light.
so just
It's only making
don't
it
write it down.
What's making bigger?
But why does it spread?
Why does it spread?
Because
This is how waves behave. If you think about wave traveling under a bridge, it will spread out after it passes through the bridge. Waves don't travel in straight lines. They travel outwards. Are you trying to do it? You can't, because we need a single light source. The room is too bright. Yes.
I can know how to do it, but it won't be. It will be circles. No, this is too big.
I don't know, way too big. I don't think you can do it right now with that paper, because the paper needs to be darker paper. Yeah, because the light will travel through that paper.
Give me your paper.
No, please.
I can do it.
Please, listen to me. If you want to see this, you can just go to YouTube and type this in, and you'll see many videos of people doing this.
But it can't be like too many like that. It's only 2. But it's bigger.
Look! Look! Shh. The reason it's many is because the waves meet many times. Like, for example, like this, look here. This one meets this one here. So this one will travel along and make a bright spot here. You know, this one will meet this one here. It'll make a bright spot.
Only 2.
Not for that size.
Oh my god.
Which size?
They must be very small and very close together.
As big as the wavelength.
Yeah. You want like nanometer. Nano.
This is not some kind of diffraction.
Yeah.
Yes,
Yeah.
that's how you spread.
Diffraction. Yeah. Yeah. Oh my goodness. Draw this, please. Thank you. Have you drawn it? Beautiful. Okay. Continuing. If 2 in-phase coherent waves are emitted from 2-point sources and then later superpose on a plane, we find that the wave produced on the plane will have an alterations of maximum and minimum intensities. In other words, dark and bright spots.
If we do it on a rocket, we'll have the same result.
On a what? We've talked about this. Now, if it was sound travelling through the 2 slits, instead of having bright and dark spots on the wall, you would have places of loudness and quietness. This is called 2-point source interference pattern, or just interference pattern. So with light, it makes dark, bright, dark, bright, dark, bright. With sound, it makes loud, quiet, loud, quiet. These are called interference patterns.
Does this have any applications in the review?
Yes. In fact, more so the next lesson, we can use things like this to reduce sound produced by factories and things like that. I drew the diagram already and it was beautiful. Okay.
Do it right.
No, it's okay. Interference pattern is the key word here that I want. Now, a diffraction grating is just a piece of plastic. What Fuan was trying to make a moment ago, it was a diffraction grating. A diffraction grating is a piece of plastic usually, or paper, with many slits in it. So you can buy these online quite cheaply, they're only like $1. It's used to take one light wave and split it into two light waves. This is what it looks like. So this is what you need to make. These need to be very, very small and very close together. These are called slits. So this is a diffraction grating. So when the light comes in and hits one of these, it can split it into two separate sources. The reason you have so many instead of just one is what? What do you think?
Maybe so something related to the wavelength.
More interferences, produce more waves, more sources.
Much more boring than that. The reason there are many slits is because you don't know where the light will hit the slit. It's practical. If you only have two slits, you need your light to perfectly hit the two slits. By having many, many slits, you don't really care where the light hits on the grating. Once it hits somewhere on the grating, it will split between two slits. What's wrong, FF? What? Not all things in physics have to be amazing. Some things can just be practical reasons. This is real life. Can you write this down and draw, please, this diagram? Fuang, if you wanted to, you could buy this online for maybe $1.
Never.
And then, if anyone had one of those red lasers, you know the red laser light? You could take the red laser light and shine it through the grate and it will split. And you'll see many dots on the wall.
I wanted to ask, because we did those with lasers.
Yeah.
Not bulbs.
Yeah. Well,
So what's the difference in the wavelength? Which one
you
is
can't really use I know in the picture I had a light bulb, but it really, to be more accurate, it needs to be no, it doesn't. No, it could be a light bulb. It just it makes a clearer image if you use a single color of light, like a red laser. But you could use white light, and later we will discover what the difference is in the image. It will still make an interference pattern, but a colorful one. Yeah. Does anyone have one of those little red laser lights?
I had a green one.
Sorry, it could be a green one, yes.
They took it in the airport.
Because they thought you were a sniper.
They really took it in the airport. Because I use it for my camera for photography. I use some nice tricks with it. But they didn't allow me to take it.
What airline?
It's not the airline, it's the airport.
Oh, the security.
Yeah.
Here?
What airport?
Heathrow.
Heathrow? They're a little bit more edgy over there.
Here they were so nice. Did they check you?
Over here, no.
Yeah, we just walked.
And they
There are
made
no
me wait for
machines.
7 hours.
There are no
Huh?
machines.
They made me wait for 7 hours.
Why?
Because it
But
was
no, when
foggy
you're traveling,
and planes can't fly.
But you said if you use my laser.
When you're traveling from here, we're gonna check you. If you have something.
I stole that laser from my school's laboratory.
You've just confessed onto YouTube, where some people watch my channel. Alright, have you drawn this? Yep. Maybe I'll buy one of these online. We can get a laser and shine it through sometime. I'm sure They're not that expensive, are they, those lasers? $5 maybe?
The green ones are expensive, the red ones are.
The colour is not important to me.
But we can still do this with the paper and the phone flash, but not fringes. The bright circle and dark circle and bright circle.
Okay, maybe it's worth buying. Right, some terms here. So, slit separation, D, small d, is the distance between the two sources. So on my picture here, this is, let me draw it again here, a bit neater. We have, this we call D. Fringe separation asks the distance between the fringes. So you'd have a bright spot here, and then one here, and then one here, and then one here, and then one here, etc. This distance here is S. Angle, theta, the angle the wave makes with the normal to the plane. So for example, here, this could be theta, for example. And just to make the distinction, we call the first one 0, this one 1, this one 2, this one minus 1, this one minus 2. This is called the order of the fringe. D is the distance between the screens and the light source. And then the order N is the position. So these are all the terms, and here it is on the diagram. So you can write these down and add it to a diagram like this, please. Yeah, you want the terms first, yeah? The angle, yeah? That's it there. Huh?
Also can do that.
What?
The angle the wave.
The angle the wave makes, yeah? What's wrong?
If you read the whole sentence, it's right.
Yeah, but what part of the English is confusing here?
The angle, the wave, the.
Oh, to theirs. Ah, yes. That is okay.
What do you mean by plus minus?
Plus for positions up and minus for positions down. So you see here, one for the uppers, negative, minus one for the lower. Wrote this down?
Drew it.
Like a boss?
Like a big boy.
Nice. You got this?
Not the images.
Okay, to the picture now.
To the wall.
Why is it only Wednesday? Do you want to draw this?
This is what I drew. So did you write it? I told you I drew this.
try not to listen to you.
And 0 is the middle.
N equals 0 is the middle.
The brightest one.
Yes. It will be brightest.
What's brightest?
Yeah.
The sun is very bright.
Yes, it is.
The telephone flash is not so bright.
Yes.
The strong light is bright. The weak
I got
light
this.
is not bright. Then
Bright, then.
not bright.
Yeah, dim, the antonym, yeah. Anti-bright.
Oh, physics teacher.
The old physics teacher was dim.
I had an old physics teacher.
Yeah.
That's why he used dim.
Well, what would you say instead of dim?
You're not using dim.
I say bright.
And
Dark.
Dark.
yeah, we use dim, not dark.
Yeah, but then it was dark. Not dim is not dim.
It is. Dim is the proper form. He's right.
Old is good.
Huh?
Old is good.
Oh, this is good. Yeah. Yeah.
Gold. Not good. Gold.
Oh, it's cool.
Old is gold.
Yes.
I've never heard this expression. I understand it, but I've never heard it
Really?
before. Yes.
Wow.
Old is gold.
So,
You know why?
Cultural difference.
No, because you don't use social media as much as we do.
That is true.
Because of your.
That is true.
phone.
That's true.
it's an American expression.
Is it?
No, it's not American.
Look, you
The
leave
easiest for
this phone
users-
out of this.
The Z, the small Z.
Yeah.
It's an opening, like for the light to pass through. Or
It's the distance between the
The
two
slits.
openings.
Oh,
Yeah,
okay.
the two slits. Yeah. Okay, continue. So let's see. Well, yeah, actually,
Speak of the devil.
this is my automated text now. Let me just check. The next bus is at 4:51.
Oh.
4:54.
Right.
It's-
4:57 is no problem.